Hi, so for today we're going to talk about modulus of a complex number, and this is still a continuation of our series of studies with advanced engineering mathematics. So first, we are going to define what is a modulus. So for example, we have a complex number. Let z is equal to x plus iy, where x and y are real and I is equal to the square root of -1. That's a complex number. The non-negative square root x squared plus y squared is called the modulus, denoted by this symbol. It's like in absolute value or magnitude in terms of physics, okay, of z or mod z. So the modulus is simply the square root of the sum of the squares of the real parts. Okay, the coefficient of the real plus the coefficient of the imaginary part. So x squared, so hence we have a formula x squared plus y squared. That is the non-negative square root, okay, of x squared and y squared. So for example, in this first problem, for number 1, if z sub 1 is equal to -1 plus I, z sub 2 is equal to 2 minus 3i, find the modulus of z sub 1 minus 2i minus 3. But before that, let me just give you a very basic example. What if we want to get the modulus of z sub 1? And we know that the modulus of z sub 1 is negative z sub 1 is equal to -1 plus I. How do we get the modulus of that? So we simply what? Get the square root of, okay, the sum of the squares of x squared and y squared. In this case, the x squared here or the x here is -1, okay, squared, plus, that is plus, okay, whatever the coefficient of the imaginary part. So we have an I here. The coefficient, we know that we have 1 here. So that's 1 squared. Okay? So if we're going to get the modulus of this, simply it is square root of 2. Okay? That is simply square root of 2. And if you can notice, the modulus is always a positive number. It can never be a negative, because if we evaluate a negative inside the square root, that would be an imaginary number. Okay? So the answer should be always a positive real number. Okay? In terms of if the given is always in terms of complex. So let's try to analyze this. Z sub 1 minus 2i minus 3. So of course, first we need to simplify whatever is inside the modulus operation. So we have -1 plus I minus 2i minus 3. So we simply evaluate this first, simplify this. We have -1 minus 3. That is -4. I minus 2i is simply -I. And we get the modulus of that. That should be -4 squared plus -1 squared. Okay, so what will happen here? This should be -4 squared is 16 plus 1, that's square root of 17. Okay, it is a non-negative square root. Okay, so it's always positive. So for number 2, given the same z sub 1 and z sub 2, how are we going to find the modulus of z sub 1 plus z sub 2? Okay, simply substitute -1 plus I plus z sub 2, that's 2 minus 3i. Then we have to simplify this, -1 plus 2, that is 1. I minus 3i, that is minus 2i. And we get the modulus of that. We have 1 squared plus -2 squared. And that is simply equal to square root of 5. And that shall be our answer for this problem number 2. Okay, let's try again another problem for number 3. Find the modulus of z sub 1 squared minus 2 minus I. So we simply first substitute the value of z sub 1. We have -1 plus I, this is in terms of squared, minus 2 minus I. Then we evaluate this, we simplify. Okay, so we have 1, okay, minus 2i plus I squared. Okay, if we expand this, so this would be minus 2 minus I. So we simplify. We know that I squared is equal to negative 1. So negative 1 multiplied by positive sign, it would become negative 1. So 1 minus 1. So this is simply negative 1. So 1 minus 1, these 2's will cancel. So we have negative 2I minus I. Okay, and then we have negative 2. So we have negative 2. Okay, we have negative 2 minus negative 2I minus I. That's negative 3I. So if we get the modulus of that, that should be negative 2 squared plus negative 3 squared. Okay? Let me just arrange my square root sign. Here it is. So the answer for this problem would be square root of, again, 13. Okay? Because 4 plus 9, that is square root of 13. That's the modulus of this complex number. So for number 4, let's try again. Number 4, the modulus of 1 minus a sub 2 squared plus I. Okay? So first, 1 minus that a sub 2. A sub 2 is 2 minus 3I squared plus I. Okay? Then what are we going to do? We expand this. We have 1 minus, we have 4 minus 12I. Okay, 2 times negative 3, negative 6 times 2, it's negative 12I minus or plus, sorry, because we have a negative here, that is 9I squared. Okay, 9I squared plus I. Okay, don't forget to distribute first the negative sign because of this minus. So we have 1 minus 4 plus 12I. Then we have minus 9I squared is negative 1. Okay, plus I. Then we simplify this. So 1 minus 4 is negative 3 plus 9. Okay, because of negative 9 times negative 1, that's plus 9. Negative 3 plus 9, that is 6. Then we have 12I. Then plus I, that's plus 13I. Then we get the modulus of that. So the modulus of that would be, we have 6 squared plus 13 squared, square root. Okay. Then we have an answer of, this is 169 plus 36. That's 200, square root of 205. So this should be our answer for this problem. So for number 5, let's try again another problem. The only way for you to get better in this topic is to actually solve as many problems as you can. The modulus of 1 minus I all over 1 plus I. So still, we need to simplify this to eliminate the I in the denominator by multiplying this whole term by its conjugate. So we have 1 minus I. This is 1. Then when we have 1 plus I multiplied by its conjugate, so that would be 1 minus I, conjugate of the denominator. So we have 1 minus I over 1 minus I. So we're going to perform the multiplication, numerator by numerator. This is again, we can solve this really quick. Okay, so we have 1, okay, then we have 1 minus 2I plus I squared. Okay, we simply expand 1 minus I squared here, which is this. Okay, over this is 1 minus I squared. And then we simplify. We know that I squared is equals to negative 1. Okay, so we have negative 1 here. And then we have 1 minus the negative 1. Okay, so what will happen here is that, as you can see, 1 minus 1, this would cancel out. Then we have 2I over okay, over 2. Okay, so this would cancel the 2's here. So we are left with simply the modulus of I. And the modulus of I, for the x part, we don't have any values. That's 0 squared. Then for the I, the coefficient of this is 1. So we have 1 squared. Then we have square root of 1, and that is simply equal to 1. Okay, for number 6, let's try the problem 1 minus I over 2I. Same process that we're going to use here. We multiply the equation or the imaginary number by its conjugate of the denominator. So we have negative 2I multiplied by negative 2I over negative 2I. Then we have the result as negative 2I plus 2I squared over negative 4I squared. And we know that the I squared is equal to negative 1. So we have negative 2I plus 2 times negative 1 over negative 4 times negative 1. So we have now negative 2 minus 2I over 4. Okay? And we can further simplify this by factoring out 2 on the numerator and the denominator. So we have negative 1 minus I over 2 times 2. So these 2's will cancel. So we are left with negative 1 minus I over 2. And we can rewrite this also, okay, the result as this, in order for us to easily see what is the value of the x and y here. Okay, so the values are both negative 1/2. So we're going to get the sum of the squares, okay, the square root of the sum of the squares of these two x and y. This is the x and this is the y in an imaginary number. So we have to take the square root of that, okay, and that is basically what? That is square root of course, this is squared. We have 1/4 plus 1/4. Okay, and then we have square root of 2 over 4, that's 1/2. And we know that this is equivalent to square root of 1 over square root of 2. And we know that square root of 1 is simply 1 over square root of 2. And we want to rationalize the denominator by multiplying it by square root of 2. So we have square root of 2 over 2. So this must be our answer for this problem. Okay? How about for number 7? Let's try number 7. Okay? So for number 7, we have the modulus of I all over 1 minus I, okay, plus the modulus of I all over 1 plus I. So the same technique that we're going to use, we need first to eliminate the I in the denominator of each term in order for us to proceed and get the modulus and add the results. So we have I over 1 minus I, that is multiplied by the conjugate of the denominator 1 plus I, and then that is plus I over, we have 1 plus I multiplied by 1 minus I, the conjugate of the denominator. So we know that we can get that easily. We have I plus I squared, numerator times numerator, denominator times denominator. We have 1 minus I squared, and that is plus, okay, here we have I minus I squared. Then we have 1 minus I squared. As you can see, we have the same denominator. So we can technically combine them, okay, but later, okay. So we have I plus I squared. We have I minus 1 over 1 minus the I squared is negative 1. Then we have plus, we have I minus negative 1 over, we have 1 minus negative 1. Okay, the modulus of that. So we have 1 minus I, or negative 1 plus I, I'm sorry, okay, over 2. Then we have plus, we have 1, okay, plus I over 2 also. Okay, 1 plus I over 2 also. So we have 1 here, then we have the plus I here. So we get the modulus of each, then we add. So we can rewrite this as negative 1 half plus 1 half I, the first term. And then the second term we can rewrite as 1 half plus 1 half I. So as you can see, that would be what? 1 half squared, or negative 1 half squared plus 1 half squared. Okay? And then plus, we have almost the same, 1 half squared. Actually, they are the same. Okay? Square root. And we have evaluated this a while ago. Okay? We have evaluated this on our previous example. We know that this is only equal to square root of 2 over 2. And that is still the same, no? Though it has a negative 1 here, if it is squared, it has the same value as this. So we have plus square root of 2 over 2 also. Okay? So what will happen? 1 half plus 1 half, that would become 1. Okay? And then we have square root of 2 as our answer. Okay? I hope you are still there. You're learning something new. So let's try another 2 examples here. So we have number 8. Okay, if z sub 1 is 1 plus I and z sub 2 is equal to 2 minus 2I, then we're going to find the modulus of z sub 1 plus 2 z sub 2 minus 2 plus I all over, we have z sub 1 minus 2 z sub 2 plus 6 minus 3I. Okay? So we simply substitute first. So we have z sub 1, 1 plus I plus 2 times z sub 2. So we have 2 minus 2I. Then we have plus I. All over, we have z sub 1. We have 1 plus I. Substitute it only. Minus 2 times z sub 2. That's 2 minus 2I plus 6 minus 3I. Okay? So find the modulus of that. Again, we're going to simplify first this one. So we have 1 plus I, distribute the 2. So we have plus 4 minus 4I plus I, all over 1 plus I. Okay, distribute the negative 2, okay, in this term, along with its sign. So we have negative 4, then this becomes plus 4I plus 6 minus 3I. Then simplify. So we can simplify this. So we have 1 plus 4, that is 5. Okay. Oh, I forgot. Wait, I forgot the minus 2 here. So I still have minus 2 plus I here. We have minus 2. So we have still minus 2 after the 4I here. Minus 2 plus I. Apologies. That's a mistake. Okay. So we have minus 2 here. We added minus 2. We forgot that. So upon simplifying, we have 1 plus 4. That's 5 minus 2. This becomes 3. We have I minus 4I. That's negative 3I. Okay, plus I, that's negative 2I. So, simply these i's will cancel, okay? I mean, that not cancel, it will be added as 2I. Okay, this I and this I. 2I minus 4I, that's 3 minus 2I. That's correct. And in our denominator, okay, we have 1 minus 4, that's negative 3, plus 3, negative 3, okay, I mean negative 3 plus 6, so we have 1 minus 4, negative 3, plus 6, that should be 3, and then simplifying our imaginary terms here, so we have I plus 4I, that's 5I minus 3I, that is 5I minus 3I, okay, that's plus 2I. Okay, then again, that is not the same, so we cannot cancel. This is a minus, this is a plus, so we still have to multiply it by its conjugate, the denominator's conjugate. So we have 3 minus 2I over 3 minus 2I. Okay, so what will happen here is that We have what? We have 9, okay, negative 2i times 3, that's negative 6i times 2, negative 12i squared. The last term, that's plus 4i squared. Okay, all over, we have 9 minus 4i squared. Okay, and we know that I squared is simply equal to, okay, negative 1. 9 minus 4 times negative 1. So we have this, the modulus of, simplify this, we have 9 minus 4. 9 minus 4, that is 5. Okay, and then we have minus 12i in the numerator. All over, we have 9 plus 4, we have 13. And get the modulus of that. So that is, it can be written as 5 over 13 minus 12 over 13i. So get the modulus of that. That is 5 over 13 squared plus negative 12 over 13 squared and square root of that. Okay? So if we're going to simplify this, so we have 25 over 169 plus 144 over 169. So we can add these two. Okay? Because they have the same denominator. So 144 plus 25, okay, is 169. So we have 169 over 169, which turns out to be equal to the square root of 1, and square root of 1 is simply equal to 1. So our answer for this full term is only equal to, yes, that's correct, that's equal to 1. And down for our last problem for this video. Okay, so for number 9, we have I over 1 minus 2i, modulus of I over 1 minus 2i, minus the modulus of I all over 1 plus 2i. Okay? The same process. We multiply it by its conjugate. Okay? Let me just change the colors. So, by the denominator, the conjugate of the denominator. Okay? And then we have minus, we have I over 1 plus 2i. Then we have 1 minus 2i all over 1 minus 2i. Okay? So, numerator times numerator, that would be I plus 2i squared all over 1 minus 4i squared minus, again, the I minus 2i squared all over 1 minus 4i squared. And then we evaluate. I squared is equal simply to negative 1. Okay? So, all over 1 minus 4 times negative 1. Okay? The modulo of that minus, we have I minus 2 times negative 1 over that, this is minus I minus 2 times negative 1. Okay, all over 1 minus 4 times negative 1, the modulo of that, modulus of that. So, what are we going to do here is that we have, simplify, we have negative 2 plus I, okay, all over, that is equal to 5, okay, and then minus the modulus of I minus 2 times 1, that is 2 plus I, okay, negative 2 times negative 1, okay, that's 2, okay, and then we have a positive I, so that becomes 2 plus I. Let me just rewrite this. Okay, that's all over the same 5. Okay, this can be rewritten, the first can be rewritten as 2 over 5 plus 1/5 of I minus the modulus of 2 over 5 plus 1/5 of I. So get the modulus first of the first term is this one, negative 2/5 squared plus 1/5 squared. Okay, then that's taking the square root of that. Okay, and then minus 2/5 squared minus plus 1 over 5 1 1/5 squared. Okay, So if you're going to observe that, okay, this one is also equal to this, okay? Because no, even though it has a negative here, if you square it, that's the same answer. So we have the square root of the 4 over 25 plus 1 over 25, okay, for the first term. 1 over 25 minus, that's the same, okay? 4 over 25 plus 1 over 25. So obviously, this has to be equal to 0 because they are really the same, okay? Obviously, so this has to be equal to 0. So the modulus of this problem is equal to 0. So, and that's all for today. Thank you so much for listening. I hope you learned something from this video. And if you are new to my channel, please don't forget to subscribe and hit that like button below. So, comment down below your thoughts about this discussion. So, thank you so much. I hope you learned something. Again, this is Engineer Abat. See you again on the next video.